Well, Brocky Tech here. We believe technology is for everybody. So I want to share my engineering knowledge and hopefully encourage all of you to pursue an engineering degree, discipline, or even just a hobby. So this is going to be a digital output for the Arduino tutorial. What you're going to need is wires, some sort of jumper wires, an Arduino, and then you're going to use some LEDs. So on these LEDs, remember the long part is where your positive voltage goes in, or your cathode. I use 2 on this one. And then you're going to need a resistance. I'd say at least 470. I'm using 1,000. And then also you're going to need a board. All right, we're going to start talking about the different configurations we can have on our output on our Arduino. So we can either run the LEDs from the high side or the low side. All right, a little better explanation. I looked through it and I'm like, well, I didn't probably explain it properly or thoroughly. So I'll do a quick explanation here. So high side driver just means that you're going to have a voltage source that is fed into a gate or MOSFET switch. So that MOSFET switch is going to be ran or controlled by the controller. And then the output of that MOSFET gets fed into a load, so if you have a light, it'll turn on the light from there, and then it's tied to ground through that load. So on a low side driver, it's the opposite. You're going to have a voltage source that gets fed into a load that gets fed into a MOSFET and directly to ground. Now you're going to have a switching mechanism that goes from the controller to that MOSFET to turn it on or off. So that's the distinction. High side is the loads after your gate, and on the low side, the load is before your gate. So then you have low side switches. Why do you have 2 of them? Well, each one of them are good for one thing or another. So you have good PWM control on your low side switch. The disadvantages of these is you have to have multiple fusing mechanisms. So you're going to have one on the low side that turns it on or off based upon that. And then you're going to have another one that feeds into it. One thing we had when I worked in automotive, we always had to add a fuse onto this. And so that always created issues. Well, it also creates a safety issue that is if you're driving an output that you have to turn off, if you have a short to ground condition, you can't turn it off. It's stuck on. So typically we'd combine the high side with the low side because we can control the on and off condition. But like if you have a short on your low side, you can't turn it off. So there's a good example of a high side and a low side combo. That's in your typical H-bridge driver. It uses both the high side and the low side. It does it for controlling where the current goes. So when it comes to your microcontroller, this does not have any current limiting on the outputs of your driver. So you need to be very careful and not burn these or blow these up. This is why I don't ever recommend running loads off of this. But for this example, we can run LEDs fine just off of these, but we need to add a resistance to these. So for the Uno Max R3, the maximum current that you can put on the output on here is 40 milliamps and total of 100 milliamps. So we'll use a 1K resistor on a 5-volt rail that'll output a 0.5 milliamps. So we're good there. All right, for this first one, we're going to run the digital high side as it's shown. So we got the pin number 6 that runs out to the LED, which will be sourcing the voltage. And then we have the LED and the resistor. I actually show them backwards on here, but that doesn't matter. And then it's ran to the Arduino ground. So that's how we're going to set this circuit up. All right, let's set up the code. Let's define our pins. So we'll call this one LED 0. We're going to set this to 7. Void setup. Now we're going to set our pin mode, and we will say it's LED 0, and we'll designate this as an output. Now we can turn these on and off by using the digital write function. So to do that, do digital write, and then you're going to put the pin number and then the state that you want the LED to be in. So here we're going to enter LED 0 here, and we're going to set it to high. We're going to delay, and we're going to delay, let's delay 1,000 milliseconds or one second. And then we'll do this again. There you go. That's the blink. Oh. All right. So it's done compiling. Make sure we have the right COM port. By the looks of it, we do. All right, let's execute. Actually, no, I don't even have it plugged in. All right, let's execute this and see what we get. Had the wrong pin. All right, so it's blinking at a frequency of 1 second. All right, for this next one, this is what we're going to do. We're going to have the source power come from the 5-volt rail on the Arduino. And then that's going to power through a resistor. I got it backwards again here. It don't matter. Resistor to the LED, back to the microcontroller. Now, I simplified this. There's more circuitry here, but this is essentially what we're doing. Let's set up this second pin, because we're going to set this up as a low side. So we'll take this define. Let's set it to LED 1. And let's set it at 6. So this output mode is going to be the same, but we're going to set it to LED 1. See, when you use these variables multiple times, like here, instead of going in and placing it multiple times, you just define it once and you call it out everywhere like that. All right. So most of this is just copy and paste, which makes it easy. Now you're going to notice something. I have these LEDs. They're crisscrossed. Or the lights are going to be show inverse. So when the LED 0 is high, the LED is going to be on. But when the LED 1, when I have it set to high, the LED is going to be off. All right, let's upload. And let's see what we get. There we go. They're doing what we're expecting them to do. Good on ya. All right, that includes this tutorial. So I did a bunch of tutorials already for the microcontrollers, an introduction, a digital input, and analog input. And so I'm going to go ahead and link those links there below, somewhere around here. And then I'm going to go ahead and do next an analog in or an analog output or PWM output. And then also an introduction or a better thorough explanation about code. So I have the blink sketch that we just did, and we're going to transform that into a function to where we don't have to use that wait function on our code, because that's essential, because you can't run your microcontrollers like that, because you'll wait the executions of all your commands if you set it up that way. So, hey, if you liked this video, hit a like button, subscribe, notifications, and follow me on Twitter. I got a Twitter. Nothing spicy there, but have a fantastic day.